So the topic today is what you've done using Copilot Agent Plugins and using your My Calendar. And I think you're using Azure Functions to manage the routing of that. So I won't take too much of time, but I would love to see a demo of just what was the thought behind it, why you did it, what problem does it solve, and then just demo it, and then we can just talk through it after that.
Exactly. So first of all, when it all started, when I started to think, okay, everyone in the market right now is started to think about, okay, building agent, and we are talking everything about Copilot Chat, but you can see the common theme. Everything we are talking about here is more around conversational AI. It is around chat interface. You type something and you get a response and so on. And after 2 years right now, with this kind of hype for everything generative AI and so on, I hope that everyone started to see that chat interface is not the solution for everything. Yep. So we have some kind of a challenge with this kind of chat interface. For example, to get a value, you need to type something. You not get a value at the first site. Somehow you need to type something to get a value. Also, you need to master this kind of prompt engineering and all of this kind of things. And I started to think, okay, maybe after the hypes started to settle down a little bit, we started to see something new coming. Also, Satya discussed this, that we are seeing some kind of a complete revamping, shifting of SaaS industry and SaaS application. And this is where the idea of agentic experiences come to me, saying, okay, maybe this is the new experience in the new reinvention of SaaS will look like when you have this kind of user experience that is powered behind the scene by agentic layer. So it will not be pure service or business logic like before, but we have some kind of intelligent component, which is the agent layer in the agentic layer that will drive this kind of experience in the future. You can see the layer itself is very simple, similar to what we used to have. So it is the user experience layer or the experience layer, and then we have the agentic layer in the middle, and then we have the model that actually driving the agent, and then we have any data which is connected to the model, and the integration. If you have line of business application, in our situation, it will be the Exchange calendar, for example. And so you can see everything. It is completely clear, but I would say the only two very important features that make all of this architecture working is actually here. If we just zoomed a little bit, and here, this is the reading path, and this is the write path. And actually, what makes it work is actually the service structure, the AI response with the structure output. So this is one of the new feature of LLM, when you can ask the model to respond with some kind of structure output. And as you can imagine, if you are building any user experience, you need to have some kind of model. You can't just waiting for some kind of text and expect the UI will render it. So you need to have a structure, and this kind of structure output is the key to make it happen. And when we are talking about the update path, this kind of AI tool calling, this is actually what make it work, because the agent also, we need to figure out from the data that will come, which kind of argument I need to extract that will fit this kind of call, and then do the call and update whatever data or line of business application in the background. So I would say this is the two important features that make all this kind of architecture working, is the structure output and the tool calling for LLM. So awesome. The idea, again, is very simple. You have a SharePoint web part, and the idea of the web part that it will scan. This web part will show you the whole agenda of your day, all the meeting of your day. And of course, it will come up with some kind of facts about the meeting, like the meeting title, the meeting time, the meeting attendees, and so on. And then it will use the agent in the background to start generating some kind of a summary about every meeting, and then also some kind of preparation tasks. So to prepare for this meeting based on only in this kind of solution, because it is very simple, based on the title, the agenda of the meeting, and the description of the meeting, it will start to think, okay, maybe you will need to do 1, 2, 3 to prepare for this kind of meeting. So this is how this solution is working from the UX layer, and in the background we have this kind of agent, and powered by Copilot Agent Plugins for sure, to use GPT-4o Mini in the background to get all your emails from Exchange, and then do everything that we mentioned about. And of course, to make it happen, as we are going to see also during the code walkthrough, we will for sure use the structure output to extract specific business model or object to send back to the SharePoint web part. So this is the idea, and this is the power of CAP, I would say. So it gives you some kind of natural language coding over the Graph API. So you don't need to know how to call the Graph API, how to extract the data, and so on. You don't need to know anything. You just type your prompt. Exactly. You just ask the question in natural language, and then Semantic Kernel will using the CAP power to do everything in the background and retrieve the data for you.
Perfect.
My last slide here, I just wanted to explain what we are going to show after the demo from a code perspective. So what you can see is that we have the SPFX web part already in SharePoint. So you can, of course, debug it from your workstation connected to SharePoint, Workbench, or whatever, or you can just build, add it to SharePoint. And then SharePoint can, in production, connect it to everything over Azure. So Azure function, where the agent is living. And of course, to make it secure, we needed to implement the built-in authentication with app service authentication. This is what I have for my calendar today. So if I open this is the first meeting with description, with big agenda and so on. And actually, this meeting is created by me, and also this is created by me. This is we talk about agentic experience introduction, and the last one is actually created by Megan and sent it to me. And again, we are talking about the different Microsoft AI agent and so on. So this is the 3 meeting we have in today. And if I opened my SharePoint web part, as you can see, of course, I'm not refreshing now, but actually this is a rendered instance of this. So this is the meeting title. And start date, end date, and all the attendees. I'm not sure if the screen is clear for you. Or
no, it's clear. It's
okay,
clear.
Fantastic. Yeah. Okay, so this is the attendees. This is the meeting summary, and this is where this is coming directly from the agent. So this is still coming from the agent, but actually the source is coming from
M365.
Exactly, but this is where the agent started to add its intelligence to generate a summary and then generate some kind of steps to prepare for this kind of meeting. So and then we have another meeting, and then we have the third meeting.
Right.
And a small things that's happening in the background. This kind of ordering of the meeting to move exactly, you will see in the background that, again, I am not doing any code, not writing any code to do this. The agent is doing it for me with just 3 words. I'm asking, please order the meeting, and then it will make sure to make the meeting ordered by the start date. Currently, this is written, as you can see, in English, but let's imagine that I am opening a SharePoint, in different language. Let me say, and actually, so I forget to I just maybe okay, I just wanted to change the language of the site so you also can see it. But anyway, so let's just change the language here. I said my preference language, I will be just in Deutsch and move it to the top, and I will just refresh. Of course, there is no any exception handling or whatever happening here. So if it's fail, and we just need to refresh again, and that's it. So
exactly.
But let's see.
So what's happening here is that the SPFX web part is making the call again, and now because of the regional settings that you have for German, it is going to flip it, and as we can see right here, it's giving you German in terms of what the synthesis part of what's happening.
Exactly, and actually, again, as mentioned, everything here is coming from the agent. What I did in the prompt, and it is great to see it in the prompt when we move. Actually, I told the agent not to translate this or whatever start date or attendees. I just wanted you to translate this kind of part, the meeting summary and the recommendation, and the agent follow exactly what I am talking about. And again, let's imagine how you can do this in the past if you needed to implement feature like this. And again, now it is just a 3-word. I am asking it to please translate in the user language. And even in the background, when you see how this is architecture, the user language is actually taken from the HTTP response header or request header, which is not actually English or Deutsch. Actually, it is written as EN or DE. And the agent was very smart to understand, okay, I see EN, it means that he wanted it to be in English. I see DE, he wanted it to be in Deutsch, and so on. So I did nothing. So I just have, exactly.
That's
so
smart.
So
there's a lot that you can get from environmental variables to pass to the LLM that allow it to make decisions for what the user needs to see. That's pretty smart.
Exactly, and this is the power of the semantic kernel variables, I would say, or parameter, because this is where you can just start it to feed external signal from your environment, as you mentioned, like the preferred language, and maybe also like the date, because this is very important when we are seeing the prompt, how the LLM will know exactly to filter by today meeting.
Yes.
And we are going to see this also in the demo. But before moving to the code itself, the final thing I wanted to show you here in the browser is actually how the setup is done in the cloud in Azure. So you see here we have resource group. When I click, I grouped all my Azure function and the related artifacts in it. And when I click in my Azure function, you will see my function living here. And then when I click on authentication, this is the built-in authentication for the Azure function, you will see that I created an app. And this is actually the app that the SharePoint web part will authenticate against. So we will show this also, that how the SharePoint is using its own APIs to call to this and authenticate and retrieve the token and so on. And then we have the exposed API. Actually, this is the initial call. When you get the initial token, you will get just a token using the user impersonation scope. But actually, also, I am giving to the same app some kind of other APIs like calendar, read, write, email, and so on. And in the code, when we are going to show it, you will see that I am doing some kind of on behalf of flow, that I get the original token with the exposed API, which is this one, user impersonation. And then I convert this token to be a token valid to call graph with calendar and the other permissions we have here. So
nice.
This is what we have so far. Can you see my Visual Studio now?
Yep, I can see a Visual Studio.
Okay, fantastic.
Probably bump this a little bit higher though, because I'm worried about the present
yeah, for sure. I will increase the resolution. 1 second.
Control plus.
Yeah, exactly. So
yeah,
is this better?
Yeah, it's much better.
Okay, so actually it is working in the background, so we are debugging, so you can see, and also I will show you some kind of debug sample at the back, because this is the first time in my career history that I love reading the logs in the background. So it is really amazing.
Because it's not your code, it's the LLM, and you say, "Oh my God, I can't believe it got this." Yeah, that's so cool.
Yeah, exactly. So how this kind of Azure function is architecture here. So first of all, we have the Copilot Agent Plugin folder when we having all the plugins itself. So somehow we needed to add it here. And for Azure functions, this is very interesting because actually, by default, these files will not be moved to the published artifact, and we need to do some kind of work on the CSP project file to make it happen. I will show you in a second. Exactly, yeah. So it is not working by default. You need to do some kind of workaround to make it work.
Okay.
And then also I implemented the logging so I can see all the magic happening. So again, the logging implemented here is using the logger from the Azure function in the background. So it is integrated already. So following your great code sample and so on. And then I'm having the model that actually I am having structured output against.
For your structured output, yeah.
Exactly. So I have this kind of model. And okay. And then, yeah, of course, I implemented or re-implemented the period authentication provider when I am here, instead of using the
use OBO flow.
Exactly.
Flow.
Exactly.
Yeah.
I'm using on behalf of flow instead of just using the code auth flow and so on.
Yeah.
And then the setting. Let's start with the CS project file because this is very interesting. And here, as mentioned, so when you implement Azure function is this kind of setup, maybe I will need to stop debugging because it is delaying the rendering here. So here, this is the item group for everything related to Azure function. So this is not for us. And then this is our item group. So identity client, similar to your use case and so on. Semantic kernel, all the semantic kernel. Also, I added Olama because
nice.
Currently it is not implemented, but actually I have some kind of a factory method that was based on configuration. You can load whatever Azure OpenAI or Olama or whatever. So it is just here to implement this. And then we have all the plugins related related to plugins, core, API, OpenAI, and so on. And this is the trick I mentioned that you needed to do to make it happen in Azure, because by default, it will not be copied to the output folder. You need somehow to have this to copy the JSON file and the YAML file to the publish artifact when you publish this to Azure. Then let's go directly to it. So first of all, here we are in the main function for this Azure function, and actually how I implemented it, it is HTTP trigger function. So you call it based on URL, and that's it. And again, it is very simple, but we have small things here also that we needed to think about. First of all, you need to retrieve the files you just published, the JSON and YAML file, and the bus.get directory and so on is not working in the Azure function environment. You need to have some kind of workaround. This is where I am using the function execution context. So we have here something called function context, execution context, that you needed to get the bus to assembly. Because in the background, actually, Azure is structured this in a different manner. You can't understand the exact bus. So we are getting the bus to the assembly and then using get directory name to get the road.
To get the name of the plugins that are inside the Copilot, the caps. Oh, that's fantastic.
Yeah, exactly. So this is the first trick, and then the rest is simple, I would say. So I am accessing the request header to extract the authorization. This is where I am just using the initial OAuth, extracting it to create the on behalf of flow. And then this is the second one, the magic, when I am just extracting the accepted language header from the request to, and based on that, if the request is coming from English browser, it would reply in English. If it's coming from Deutsch browser, it would reply to Deutsch, and so on. And then to encapsulate everything, I created this class is called Semantic Kernel Planner Agent, and it takes a couple of parameters. So the root directory, the access token, we just extracted from the authorization, the accepted language, and the logger. So this is how we pass it. And then how we configure it, I will show you how this class is working, but actually how we configure it, first of all, we call planner config async. So to configure everything in the background, I will show you this. And then we execute async to get the initial response. And take this initial response and move it to another function called execute with structure output async, and then we have it to extract the structure output. And the cap is using the JSON and YAML to see how you can just format your request to call the graph and so on. But once I started to say to the model, please, I need to extract a specific schema, maybe it will just neglect this kind of information here, and it will start, for example, for the start date. Let's imagine that it is called start date in the JSON schema or in the graph schema. It will just neglect this. It will neglect this and just force it to look similar to what I am looking for. This is why I found this kind of structure output is not working directly with the cap. I needed to extract the information first and then extract the object from the information that will come next.
And I think that goes to the point that one of the things that we do in CAPS as well is that we enable strict mode on our schema. Because of the same rationale, we needed to understand exactly what we need to pass for graph to work and to have a minimal set of parameters to ensure consistency as well. So you're probably working through the same processes that we had to do as well.
Yeah, exactly. So and here this is actually the head of the agent itself is this class that actually take everything and then started to do the whole work. First of all,
this is the workforce.
Exactly. So this is where first of all we add the magic that you have hidden. I already covered
in the region settings. Exactly. And then also I add all the Copilot plugin async, and then as you can see we have the plugin names and everything. So this is the configuration part, and then let's go to the execute async, and this is where also the prompt come to play. Let me also explain how it is look like. So how it is. I have a question. I'm gonna write it down.
Yeah, sure. Yeah. So first of all, this is the prompt template, and here I'm saying to the agent, you are a helpful day planner agent. You are responsible to retrieving all today, and this is again. The first time, if you just created all today without having this and passing today date as a kernel argument, actually the agent will completely hallucinate.
It'll think it's 2023, August 2023.
Something like this. It will just think in any date and just come. And this is where you need somehow to pass it as an argument to say today this is the day, and then you pass this kind of information. And then I'm asking it to generate some kind of report. First of all, I am saying that step 1, get all today calendar meeting, and for every meeting, extract and generate the following: meeting title, start time, end time, attendees, and then also I am explaining for attendees I needed first name, last name for every attendees with a comma separation, and I give it
examples.
And then again, the other magic coming when we are saying meeting summary based on the meeting title and the meeting body. This property must be written in user language, and then I am adding the user language, and
that's the reason why everything else may be in English, but this bit right here, when you refresh, will that's smart.
Exactly. So this is how it is happening in the background, and first of all, this is the first one. So the result of this, you will get this kind of report coming, standard text report from the agent, but somehow we need to have some kind of output structure around it. This is why we implemented the second function. What the second function is doing, first of all, the second function is using one of the feature of semantic kernel, which is the structure output. And how to implement it, you need to update the prompt execution setting and then implement the response format. And actually, in the response format, you have two types to implement this. Either you are giving it some kind of JSON schema, you define a JSON schema and you give it to the response format, or actually you just create an object and you say type of object, and in the background, semantic kernel will do some kind of reflection to understand the properties of the object and create the schema for you in the background.
Right, which makes sense. Yeah, that's like JSON to C# to JSON.
Exactly. I took the easiest pass to create the object and then said type of, and then I said semantic kernel, do your magic, and it did it. So this is great. And again, how I implemented sorting, just 3 words. So invoke prompt async, you must always order by meeting start date, and that's it. So
that's it. No code.
Exactly.
This an instruction.
Exactly. So and then I added all the prompt from the last call, which is completely unstructured, the text thing. And then in the background, the semantic kernel will just go and see what is the schema of this object, and it will extract exactly what we are talking about and what we need. And let me go through the rest very fast here. I'm not sure if we have any other things. So of course, this is the function, the kernel factory I'm talking about, and currently it is very fixed, but you can imagine that you are having this kind of LLM type from configuration, and based on the type, you either return the Azure OpenAI kernel or the Olama kernel or whatever kernel that you needed. So you can make your solution very flexible, I would say.
Yeah, we do this as well inside the CAPS example by allowing you to choose from OpenAI, Azure OpenAI, and also Olama. So it's good that you provide the flexibility.
Exactly. And then, I think the rest is completely taken from your sample. So the rest of the function and also the hidden magic don't look under the hood part. And so on. Yeah,
that was my question though. So we can hold here for a minute. So one of the questions that I have, I'm wrestling. I'm not going to say I'm wrestling with it because I've already made a decision, but I'd be interested in your take. So this is moving fast. We rolled CAPS out for everyone to use. We understood some of the challenges was, having the LLM understand the prompt, having the LLM also reason over to choose the proper function, and also what parameters and stuff to send. So there's a lot that we've done inside the extension method inside semantic kernel, and there's some that we put, like you say, here in this region setting where we're just doing some tuning. The question then becomes: do we keep that here inside the code itself, the sample itself, or do we move it into the extension method so everyone can have just access to it? And the reason why we have it here is because we don't know what challenges people are going to face with the model that they choose, because that impacts what happens here, and also the type of scenarios, which is the type of prompts that you're going to provide it. So the reason why we kept it here is because we wanted to allow for that flexibility. Or there are other ways that we can say we support this model and this version of the model. Then we can move it into the extension method, and then now we because we have a contract in essence in terms of what we expect people to use, then we can abstract all of this away into a higher level. What are your thoughts on that?
I would say if we have some kind of common challenge that we know that everyone will face, we move it to the extension for sure. We don't put it here. And then we provide some kind of extensibility, and by this example, or maybe abstract method or something that you needed to implement. So if you are facing more challenge than the common, maybe you can go and implement and update whatever. But I would say if there is a common challenge, please don't keep it here. Just move it, because if it is common, no one needs to know about it every time. So
exactly right.
It just needs to work in the background.
Yeah. That's
exactly.
Fair.
So I just wanted also to show you the authentication, the peer one, because actually it is very interesting also. And because what we are doing here is the on behalf of flow. And again, it is very simple. So you are just passing it to this get access token async method. And we have this kind of pair token that we pass it to the constructor of this class. And then in the background, we creating as any normal on behalf of flow. You do the user assertion, and then you get the client acquire token on behalf of. And then, of course, you pass all the information related to this kind of client. So the client is actually created in the top here. So when we are passing the client ID, client secret, and so on, so all of this kind of information is passed to the client in the top, and then we are using the client to create the token and retrieve the access token. And exactly the second method, exactly as yours, that inject the final token to the call. To the authorization header in the bearer token, exactly as this one. The last thing I wanted to show you is the log, one sample log very fast here. So let me share it and show it to you. 1 second.
Yeah.
And then can you see my Word document? And actually,
I can.
This is the complete log for a successful run, and it is very interesting to read through. So first of all, this is the argument that I am passing. So today, and then this is the date, and then the language that's coming from the header, and then this is the prompt, render the prompt itself. So this is the prompt what I am sending to Semantic kernel, and then this is where the kernel started to call the cap, and this is the actual function calling itself, and this is the actual argument to stop 100 search and so on. So this is very interesting. So the model is calling the graph API in the background with all the information, and actually all the
no, that's because of strict mode, by the way. It knows exactly what to call. Yeah,
exactly. And the green field here is actually the content that's coming from the graph with all the meetings, all the information, all the expected schema, and so on. So this is very interesting. Let me go fast through it. And actually, this is the result, the initial result, text result. So here is the details of today's meeting. This is coming from the agent with all this information, as you can see. And then the last part, which is the very interesting part, is where I am calling the structure output. And as you can see, this is the structure output. So this is the
that's your type off.
Exactly.
Exactly. Oh, this is fantastic. Oh my God, you know what? You're giving me some ideas now as well too for what to do next. This is great. This is a great use case. This is something that you can definitely bring to a customer, and they will see immediate value and immediate impact. This is brilliant.
Yeah, I think this is all from my side. Fabian, I'm not sure if you have any more questions or not.
This is brilliant. I couldn't wait for this demo because so there's what's inside my head and how I see it, but it's always better when somebody takes it and they run in a different direction. I said, oh my God, I didn't think about that over there. So, and just watching you today, I'm thinking, there's a lot more that we can do with this extend. And I'm also thinking, how can we even take this down into a declarative agent as well too, and expose this work that you've already done to be consumed by somebody inside Copilot Studio as a DA. Not really as a DA, but having this rendered as a custom engine agent inside Copilot Studio that people can use inside BizChat as well too. I'll definitely share this with our engineers, because they're going to want to see that as well, to see if there's a way that we can actually make that experience a lot better. Because I think using Azure Functions to do this, one, it provides state, it allows for a lot of retries that's already inherently built in. It's easy to use as well.
Yeah.
So I may build in that direction. So this may be a good way for us to actually take that feedback and iterate on top of it ourselves and make it a lot better. But this is fantastic. No, thank you.